Our next speaker is Sergey Gordeychik. Sergey has been doing security research, products and services for the past 15 years, more than 15 years. Since 2011, he's director and scriptwriter at Positive Hack Days Forum, the largest cybersecurity event in Eastern Europe. Sergey has, for instance, been working at Kaspersky Lab and Positive Technologies. He's also a visiting professor at Hackerspaces University in Barcelona and leader of the SCADA Strangelove Industrial Cybersecurity Research Team. Today, Sergey will talk about how to hack software-defined networks and keeping your sanity while doing it. Let's give a warm round of applause for Sergey Gordeychik.
Hello, hello, good night. Let's start to refresh on memories. This is a big honor for me to speak on the 35C3 because my first talk here was on 29C3 with SCADA Strangelove team. And I think I can skip this introduction, thanks for our host, because everything is here. And what I want to say about me, still I am very Russian, living in Abu Dhabi and do all this stuff because I saw this album in the airplane when I fly here. So, except Bitcoin only. So let's start to talk about software-defined networks. What is software-defined networks in general and SD WAN in particular case? It's a magic. So according to Gartner, it will kill MPLS, it will replace all your Cisco and Juniper device, or Huawei if you prefer Chinese, but it's bad, you know, it's according to last news. And it will solve all your network problem because it have AI inside, and it will magically optimize network operations and do everything, including security. So because it's perfectly safe to implement in wide area networks efficiently and security. So, okay, sounds good. What is actually software-defined networks? It's so simple. If you're familiar with the routers and switches, like it's just accept packets and send it somewhere according to routing tables or MAC tables, but software-defined networks is quite different. And when we tried with our team to understand how it's work, our first impression was like this. We are hackers, we don't want to deal with this shit, but the only challenge we met before you hack something, you need to actually activate it and make it works. Which is why we start to understand how software-defined networks and SD WAN works. So what the main difference between traditional LAN and the SD WAN? In traditional LAN, you have different devices which solve very specific purpose, for instance, switches or routing or firewalling or network load balancing. In case of SD WAN, you have just a server which runs operation system. In most cases it's like Linux, and on the top of this operation system you have very specific modules like CPE which do specific network functions. It can be firewalling, it can be routing, it can be switching, it can be network load balancing. So you replace specific devices with one big server which magically do everything with AI and in the cloud, sure. So in the SD-WAN, we have several layers. So low level is data plan when actually you process packets and decide how to go it, in which way, how to firewall or drop it. We have control plan which manage different routers, different devices. We have management plan which can help to apply policies, and orchestration plan because it's serious things that should have something which called orchestration. But on the technical plan, again, we have hardware with operation system and the layer which called network function virtualization. What's network function virtualization? Is the way to apply different network functions to the specific device. It's very useful, for instance, to the network operators who will provide you with the specific box, and if you want to activate any functions, this can be a web application firewall or the sandboxes, we just upload very specific virtual machine. It can be a Docker, it can be a KVM image to your hardware, and you can start to use it. Because inside of this box, you already have all the system infrastructure, which process packets and pass it from one virtual network function to the other. This helps to organize things like the service chaining, so you can distribute different network function on the branch level, in the cloud level, or on the HQ level. For instance, things like content filtering, which can be very heavy from performance perspective, can be distributed. As example, on the branch level, you can use simple things like the antivirus to process content. On the HQ level, you can use more heavy things like sandboxing. And if antivirus or specific rules see that this content is suspicious, it will forward it to HQ through the MPLS or other VPN, and next process is in the HQ. Or you can also analyze it in the cloud through the simple things like the cloud threat intelligence, where actually your SD WAN box will send MD5 hash to the cloud and check is it good contact or bad, or send all files to the cloud to double check it. Not bad, and I think that is why SD WAN become more popular, and you can see that even military guys in US, they decide to switch to SD WAN because of security, cost saving, and all these benefits. Okay, security sounds very familiar for us, and we decide to obviously hack it. I think most of you have experience in hacking of different network appliances, and you know that sometimes you need to have complex things like RN soldering kit or debugger, G-tabulator, etc. But not in this case, because SD WAN actually is not appliance, it's a virtual appliance. And to start hack it, all you need is to go to the AWS or Azure and just activate this virtual appliance for, I don't know, $10 per month. And next step is get root on it. It's a very good talk presented on different conferences, including Zero Nights, how to hack virtual appliance, and we use this like a checklist for our research. Because if you hack in virtual appliance, you already have access to this system. You can mount file system to the other virtual appliance. You can grab etc shadow. You can find a lot of different backdoors just through the static analysis. But all the good things starts from the Google. For instance, to find admin password for one of the SD WAN appliance, we just Googled for GitHub and found that most of the scripts which use it to automate this appliance use username administrator and password versa123. And actually we found that this username and password is hard-coded there because there is no way to change it. Next step to root it is just to Google for old vulnerabilities. For instance, in Silver Peak, we found that guys had reported vulnerability in September 2015, and it's still working in March 2018. So Google works because Google Fu is strong with this one. Next thing is grep. It's always work as a strings, you know. And using grep and code word password, you can find a lot of interesting things like hard-coded password in different location in the configuration files, in the database connection string, in the system logs. Because again, it's virtual appliance and someone had deployed before you start to use it. So in the logs there are a lot of live interesting information. In the shadow file, like in the one of Cisco appliance, etc shadow file, which use DES encryption in 2018. You can do some forensic, because again, if you get virtual appliance, someone had deployed. And sometimes we're trying to hide with this, and you can see that cutting bash history, you can find that someone ram scrub AWS shell script, which actually set up a different password, etc. So if you somehow can recover this script, you can find a lot of interesting information in this kind password of admin users. And you can see that from this password you can find the hash, and next try to brute force. It just was my guess that maybe because Versa have password Versa 123, maybe other network appliance like Silver Peak have similar password Silver Peak 123, and this guess was successful. And it's good because you cannot stop the progress. If you have experience with red teaming in the enterprise network, you know that Cisco or Huawei with the administrator and Huawei 123, it's quite common password. In this case, it's more complex thing, sometimes very elite, like this stuttering network stuff, you know. But still, if you did not get the root with these simple steps, again, it's virtual appliance and you can always patch it. So you can change, for instance, hashes in the etc shadow, you can change boot script, you can change remote management configuration, the password, and next boot in this configuration and get root password to do next step, security assessment. Security assessment, at the beginning we did in very, you know, not scientific way, we just hack all the things, but after all we did some, let's say, scientific research, and we have an article, I will give you a link, like SD WAN threat landscape, with the step-by-step assessment what you should hack to get maximum results. But let's mix this thing with funny hacks and the scientific approach. From the system engineer point of view, SD WAN have hardware, which off-the-shelf hardware, operation system, in most cases, again, off-the-shelf Linux, and different virtual services. Let's start from the operation system, because again, everything you saw in the recent talk about BMC and remote management interfaces related to hardware, it still works here, unless it's disabled by the vendor, but it's highly unlikely. On operation system, we did very simple research. We just checked the patch level of the all components installed on this box. And you can see that patch level ridiculously old. For instance, the oldest things we found, it was an OpenSSL library, which was released in May 2006. It's for network devices with security functions. But our guess was that they choose this library because this library too old to be vulnerable to Heartbleed attack. And SD WAN wins because oldest library, OpenSSL library we found in commercial product was in the Siemens Semantic WinCC, which was released in 2007. So SD WAN is like old school, really. Next thing related to operation system configuration is sudo, and it's actually everywhere, and actually everywhere for management interfaces, including web services, shell, etc. And it's implemented in terrible way. As you can see, W data have all ability to execute all command, and some scripts just execute execute any command through the sudo. That is why if you have any small vulnerabilities in the web interfaces, like in this case, it's command injection, you can execute command with sudo. So it's again 1990s. Next point is software, not system, but software design point of view. From software design, there are a lot of open source components which implement IPsec routing, but from management perspective, they use mostly HTTP and things around it. So let's analyze HTTP and web management interfaces. So in this case, it's not so old school like a system side. Everything is based on Node.js and JavaScript. It's like very cool. But under the hood, you can find hardcore mix from the Perl, Java, PHP, whatever, which like, I don't know, looks like the guys developed it the last 10 years. With all this modern Node.js stuff, developers confuse the client and the server because, you know, JavaScript's on both sides, and it's hard to understand where is server with client side. I will show you examples. And there are a lot of simple things like slow HTTP DOS attacks, which should be fixed for a long time ago, but still you can stop web interface with few HTTP requests. So a few examples about client side. JSON CSRF is everywhere, so almost no web interface implement protection from cross-site request forgery in proper way. XSS is everywhere, and this is not a problem. So it's a response from the product manager of one vendor. They told me that XSS from cross-site scripting for their application is not the issue because Chrome blocks it. It's just an example of using XSS on such appliances. In this appliance, we can use a combination of the XSS and cross-site request forgery to download and upload certificate, which use it to authenticate with the server, which like control plane with management server. It's just one HTTP request. And obviously, there is no a response from the vendor. They just silently fix it. So we decide to publish it through the full disclosure. One example of the perfect authentication. So in this case, you can see that it's client-side JavaScript, which just send requests to the server, to the login status function. And if user is logged, is go to the request page. In our case, go to the username and password page. So this 100% client side. No other checks on the server side, just if you can change it. Second example is just perfect. So guy, I think he tried to port the authentication from the server side to client side. I understand what this JavaScript, which still JavaScript, but it doesn't work in browser. And he just like commented and say, if username is this and password is this, then go home. So authentication is passed. So this thing, so highlighted box. So this all authentication on this box. Next funny things which related to SD WAN is about different privilege escalation. If you're already able to get access to any of virtual appliances inside, you can try to establish connection from this appliance to other appliance through the local host function. So why it can be interesting? Because there are a lot of open source components for the remote management. For instance, like Shell in the box, which provide you like Shell through the web interface, or Munin or Solar, which like system management boxes. We just bind it to local host. So you cannot establish connection from outside because it's listening to the local host. But if you're already on this box, and you can connect from this box to local host, then this connection works. And this works because on each appliance you have a lot of virtual appliances which still listen to one IP addresses. If you have experience with the Docker, for instance, so all Docker's containers have own IP address, but from the all computer, it's actually connection from localhost. So if you own any of the virtual appliance, you can own next all virtual machines installed here. This gives us different interesting ways to escalate privilege inside the box. For instance, if you able to, let me switch to the laser pointer. You can see it? Okay. If you can get access to traffic processor, for instance, for some TCP stack vulnerabilities, next you can get access to management application, and this management application in most cases have no any traffic filtering and trust to management application of all virtual network functions which run on this appliance. So you can do horizontal privilege escalation, or next jump down to operation system level, and next go to the management plan upstairs to the management appliances. But it's really boring to find web application vulnerabilities in such big amount of code. That is why we just download this code from the different network appliances and drop it into the interactive code analysis system. In this case, we use Positive Technologies Application Inspector. And this helps us to find a lot of vulnerabilities, including such funny things like, for instance, poorly patched vulnerability in the Citrix SD WAN, which was patched in 2017, but it still works if you use not get HTTP request, but post HTTP request. So we patched it once again. In this case, better. Also, it's Yoda lesson style vulnerability. So it's obviously patch traversal, but it's just reminder that attachments lead to the jealousy and the shadow of grid that is. So if you send attachment shadow, you can get shadow file. So this is a full list of vulnerabilities we found during just source code analysis without, brain interaction. Next step is crypto, because it's security appliance. It should implement cryptography. And there are two things: it's SSL TLS and IPsec. In most cases, SSL TLS is used to protect management interfaces between the different appliances. And because it's automatic, it's use different kind of automatic setup, we found that there are a lot of things related to the unsecure configuration. For instance, we can use SSL TLS without forward secrecy. So if you have access to the certificate, you can sniff off traffic even without full man in the middle. Different things related to the old cyber suits like triple DES or RC4. For IPsec, we found that in most cases we used a very strange way to select certificate or the pre-shared keys, which in most cases just hard-coded. So one example from real life, our example we will publish soon from, again, Citrix NetScaler. These appliances use master control node protocol to communicate between the orchestration plan, control plan, and the data plan. It runs on the TCP 2156 and use TLS without forward perfect secrecy. And what's interesting, a certificate located in the home Talary user certificates and account WW data have full access to this certificate. For some reason, I don't know. Okay, it should maybe read it, but why to write? And what's interesting, all SD WAN appliances we able to find during our security assessment, we use same key pair which are located in appliance edge PM key. So all SD WAN appliances in the world used to protect communication between management engine, same key pair. So if you know this key pair, and it's obviously you can just cut it from the file system, you can passively or actively sniff traffic, do man in the middle, spoof management compliance, and if this device have any web application vulnerability, you can overwrite it. I don't know why, but maybe if in next turn we will change this certificate, you can download alt and do man in the middle again. Interesting stuff we found. We ran some tests from the DOS attacks and found that Suricata, which use it in SD WAN appliance as the IDS, is vulnerable to regex DOS. So it's old story. Some regular expression can spend a lot of CPU time if you send specific queries. It was fixed in the default Suricata kit, but still work in some modern SD WAN solution. And for sure, if you do some fuzzing, it's always work and give you some fun. Unfortunately, we cannot present reverse engineering part because most of such SD WAN solution we have restriction in the licensing agreement to the reverse engineering, but just for fun, I think that some of engineers they also love Star Wars and hate Marvel. That is why initialization functions calls Marvel sucks. So just an overview of detected vulnerabilities. So green is good or bad, so good for vendor, bad for us. We are unable to detect it. But you can see that most of classes of vulnerabilities like hard codes, broken access control, old products or Linux components or third-party components were in most of such system you can find in most of such system. So just select any SD WAN and make shut. Interesting thing in SD WAN is zero-touch deployment. So the it's a very cool feature. For instance, let's imagine that you have a branch office. You need to deploy a branch office. With SD WAN, it's absolutely not necessary to go there or establish telnet or SSH connection and try to upload configuration. All you need is just to ship this device node with unique ID, set up it through the cloud console, and ship this device to a remote location. This device will automatically connect to any internet it sees around, connect to the cloud server, download configuration, and start operation. So, for example, how it works in the Citrix system. We have this appliance which ship it to the office. It's first try to establish connection with the surrounded appliance. If no, it's try to go to the zero-touch deployment service, present own ID, and next this service will provide all configuration which you upload through the your SD WAN center. So from security perspective, this scheme looks terrible. Why? Because this SD WAN and cloud deployment server should be friendly, but any attacker not. If you know ID, if you can brute force with ID, you can pretend to be this device. If you have any weaknesses in implementation of this management servers, you can own all devices which deployed for this service. And as you can see, even Cisco, which is like the best device from security perspective, we found on this product line, let's say, have enough vulnerabilities. And this, you can see that zero-touch provisioning command injection vulnerability. So it's cloud server which to which all network device should connect sometimes. But also we found very funny things related to the distribution of this device, because as I told you in the beginning, most of such device can be activated as a cloud appliance through the AWS or the other cloud services, and we found that most of default images use old version with known vulnerabilities. So you go to AWS, you trust the vendor, you activate the system, and you receive attack because there is no vulnerability. It's remind me an old story. I'm really old man, sorry. You know, Code Red, Nimda, this kind of Kido, this kind of worms, and this real disaster when you just install fresh Windows 2000, which have Internet Information Server by default, and just connect it into internet to download patches, you receive a new infection and need to reinstall it from the beginning. So these things look similar for me, but is much worse because in this case is a security network device installed on the perimeter of your network. This overview of up-to-date statistics, you can see that very few vendors, actually no one of vendors have up-to-date version in the deployed on AWS or internet. So I think it's abuse of the force. But it's also a very interesting part of story. As a security researchers, we always work in the responsible disclosure way, and as you can see, according to this article, some vendors, they also understand that responsible disclosure is very important to communicate with community, to fix issues, and they even have product security incident response team in place. Great. But when we try to submit vulnerability report to this vendor, we are unable to find the email of this product security incident response team. So there is no pull. We tried to Google for it a different way, no luck, but we found that guys who did similar research before, when they found a great way, send email to CEO of this company. Unfortunately, my Google foo is not good enough, but I am unable to find email, but I found this guy on the LinkedIn. And he answered it in a few minutes, actually, and put me in contact. So if you're trying to deal with SD WAN vulnerability reporting, just do this way. So we prepared this table about different vendors, how they communicate with researchers. And you can see that actually Cisco, Citrix, and VeloCloud, which actually VMware, no, not bad, but all the rest, it's just a beginning. This is my favorite email from the one vendor. When we send notification, we start to ask me, why we send this email from the Gmail? Do we have official ID? What they mean? I need to present my passport or whatever to submit vulnerabilities. But the funniest thing here, this vendor wrote that their device is not generic web service, which have full access, full internet exposure. So after reading this email, I go sleep, and during the night, someone told me. So to understand threat landscape of SD WAN, we built the bunch of script which works on the top of the different search engines like Census, Shodan, Google, and use also Nmap Lua scripting platform to fingerprint different SD WAN solution. We have a article published as SD WAN Internet Census, and and also some tools which can generate beautiful maps if you want to present on the Chaos Communication Congress, because in our case it's useless. And what we found that there are not so many SD WAN devices yet in the internet, about 3,000 management interface which contains no vulnerabilities, and you can own it in a few minutes. Also we built some kind of vulnerability assessment tool which help you to find no vulnerabilities in these SD WAN devices. This example for OpenSSH patch level, as you can see, that like some CVs from 2010, from 2014, etc. This open source, you can find it on the GitHub. We have two versions. One SD WAN harvester, which use Google Shodan and Census to collect information in all those internets. And also SD WAN infiltrator, which is bunch of the network Nmap script engine scripts, and you can use it during penetration testing. So it's not necessary to be connected to the internet. You can just use it inside the network. When we did this research, we also found interesting article from Silence about dark web market, when the bad guys sell usernames and password to different network appliances, let's say enterprise level network appliances. And we found that there are some IP addresses which we found during our assessment, internet harvesting, in this list. And in our experience, there is no such things as a luck. We tried to find why such appliances can be so easily hacked, and obviously the default password, which hard-coded, sometimes never change it, was used on these appliances. We try to reach vendors and say, guys, maybe it's a better idea to use, for instance, hard-coded SNMP, not hard-coded by default community, like public and, again, public for read-write. But they told us that SNMP is off by default. But still, simple showdown search show that more than 200 users of this SD WAN, they enable this SNMP service and still use default password. So we have a lot of tools which publish it in our GitHub, and please contribute. There are a lot of things to do with the new fingerprints for SD WAN harvester and infiltrator, with SD WAN threat landscape description, with new vulnerabilities, and also it's like special CCC release. We start to publish Metasploit models for the SD WAN. So we have public vulnerability description. You can create own models for it. And conclusions. So, from in my perspective, how SD-WAN development life cycle works. So someone come with brilliant idea. Okay, let's build SD-WAN because Gartner told us that it's like brilliant to have in AI in the cloud. So what we have to do, we can download a bunch of open sources, put all together, set up default routing things, and after all, use it at the SD-WAN. So SD-WAN is a bunch of open source, which not bad, but still you need care about it, and you need install patches, configure it in the proper way, and maintain. These complex products have problems with patch management, have a lot of management interface like machine-to-machine and also human-to-machine interfaces, have a lot of weak defaults like password, hard-coded certificate, PSK keys for the IPsec, and many vendors unfortunately have issues with the patching, responsible disclosure, and this in the cloud. So if you decide to switch your network to the SD-WAN, hack it before buy, or you will fail. So thank you for your attention. I want to ask you to give big hand to the SD-WAN New Hope team, to Denis, Maxim, Nikolai, Nikita, Oleg, and Antony, who did most of the things here. I just like a front man of this group. Thank you so much, guys.
Applause for Sergey and his team. We now have about like 50 minutes for questions. And you know the rules. Please move to the microphones over there.
Any questions? Yep.
Aside from kind of generic things that any random Linux server can have on web interface and SSH, have you looked at any specific SD-WAN security problems, like with the encapsulation of tunnels or some stuff like that?
SD-WAN, you know, there is no like technology like SD-WAN. So for SDN, there is kind of protocol which more or less reuse it in different vendor, in different solution. And SD-WAN, every vendor implement things in own way. As an example, it's like Citric management protocol, etc. One thing we did here, but we didn't publish it, is for the virtualization. Because again, this VNF story, very interesting, because if you have vulnerability in any virtual function, next you can get access to our virtual machine. But again, problem here, that there is no standard, and different vendors call VNF, so implement VNF in different way. It can be KVM, it can be just a script which they upload to their appliance.
So you're saying because everyone's writing their own code, there are a lot of bugs to find for people who put the work in?
Yeah.
Okay.
Okay.
And you can just, it's not necessary to try to buy things through the eBay to hack it. You can just go to AWS and activate it for free.
Okay, Mike, one, please.
My will be simple. There was a lot of vendors that you were looking. What about Juniper SD WAN?
We don't know yet.
Looking forward for control investigation.
Thank you. We'll try.
And yes, please.
Okay, so thanks for the talk. You mentioned a lot of these virtual machines were like running in hardened Linux or something. And what are they running? It's like prehistoric, and what patch levels are they usually on? These kernels, is like always 2.6 or something like that.
Not always 2.6. It was like the worst example. So some of us like newer. So it's not necessary. Again, for network function virtualization, some vendors they call VNF just a bunch of script they download and change configuration of default sensor. And in this case, we can use very old kernel. Our way use more recent version. Sorry.
Yeah, that's okay. I mean, the hardening, how is it done usually? The hardening of the Linux kernel, is it like prehistoric or?
In most cases, no way. So no armor or things like this. No JR security or CLinux. Nothing.
Okay, thanks.
All right, your question.
Have you looked into Cisco Meraki?
No, we for Cisco we sorry, it's night. Let me find the list. For Cisco we did our exercise with the Viptela.
All right, last question over there, please.
Just advice, maybe you drop a slide in with the 90s code, they want the hard-coded passwords back.
Sorry?
Because there were so many hard-coded passwords everywhere. Maybe you should just drop a slide in the 90s code, they want the hard-coded passwords or logins back.
I don't know. So it's public things.
So was that a question?
It's just recommendation.
All right, we have a few minutes left, but if there are no questions left, then I would call it a day. So another warm round of applause for Sergey and team.